So today we're delighted to have John Chodacki and Vaida Plankytė. John is the director of the University of California's Curation Center, which is part of the California Digital Library, and Vaida is the product manager and design lead at RSpace. They're going to be presenting on some work that they've been doing together, and I will hand it over to you all. Thank you very much for joining today.
Thank you. So we're gonna just get situated. Fido, I think you're gonna be helping me with the slides. I'm gonna be speaking at just the beginning, and then Vida will take over. So she's gonna help with the slides. We're here, as Natalie mentioned, we're here to discuss our project. It's a eager funded project, NSF funded project. So we thank NSF for their support. And the project is entitled Fair Samples. I think Vida, you can go to the next slide.
Yeah.
What we're wanting to accomplish today, just hopefully we can start a discussion amongst the group here. It's really just to give an introduction to the project, give everybody some framing about who we are, where we work, and then also how we have been experimenting with end-to-end samples workflows. And so we'll be going into more detail, and Vida can talk more about the product side of what is being prototyped and tested out. But really just from a scene setting and introduction to the project and to where we're at. You can go to the next slide. We all know that samples are foundational to earth and environmental science, but workflows around them, around collecting, cataloging, managing, publishing information, they still lag behind experiences of the rest of science. And we all here, we don't have to tell you, we all here know that this is a challenge, and the ESIP community has been working on this for years on how to make samples more discoverable, more connected, more fair. And the broader landscape that we're stepping into today is well understood by the group here on the call and by the ESIP committee and community in general. But next slide. What we really wanted to talk about is our work that, it comes at this moment where the community has also created a lot of alignment. So as you are all aware, there's, a lot happening in this space. There's a lot of work that's happened around helping with stewardship and discoverability of physical samples. And so the questions that we're really asking in our eager are at this specific inflection point, how do we reduce the manual work, increase the fairness, and create workflows that researchers and field station staff can actually adopt? And so today we'll just walk through the work that we've done so far, open up a discussion about the work that we continue on, and really think about the workflows and highlighting opportunities for your input, and also really focusing on that idea of tangible workflows and ideas that researchers themselves can actually adopt. Next slide. So we're not assuming we have all the answers, but as we can see here, what we're trying to do is surface many of the challenges and work with the community to shape the next steps and what things could look like, and using the eager grant as an opportunity for us to explore them. So really thinking at iterative design and feedback stages that explore integrations that can help with field stations and researchers and samples collection in a full ecosystem, and look at way things can be improved. Also looking at how metadata flows across systems can support more connected, not just at the time of collection, but upstream and downstream, and thinking about the full samples lifecycle. Also how IGSN and other persistent identifiers can be registered at the start of such workflow and then can be used throughout. And looking at existing tools. So one of the main things we looked at is existing tools like FieldMark and RSpace, and how integrations between them can happen. And also how samples management, experiment tracking, repository deposition, how these can be supported specifically through RSpace, but more as an exemplar for workflows in general, and how the community guidance, obviously from this discussion here and others that we're having, can really help guide the next steps. And so, as I mentioned, this is a NSF funded project. So again, thank you to NSF for their support. And the funding is meant to enable experimentation, thinking about how the use of persistent identifiers can help samples management systems be more synergistic with the rest of research tools and the larger workflows. And so a little bit about ourselves, about us. Next slide. As Natalie mentioned, my name is John Chodacki, and I head up the UC3 team at CDL. We're situated at the University of California Office of the President, and our remit at UC3 is focusing on topics around research data management, data publishing, persistent identifiers, digital preservation, and skills training programs. And so CDL as a whole and Office of the UC Office of the President is our larger organizations. UC3 fits within that structure. And one of the unique ways that we help make change and think about projects is really through collaborations. And you'll see here just from this kind of logo soup that, one of that there's many projects that we're involved in that have communities and discussions around them that are much bigger and broader than just UC3, but where we're connected in through these communities. And next slide. And some of the unique communities that we bring to the table with this project are work that we've done with a project we helped lead called Fair Island, which was thinking about how to take data policies and usher them through full data and field station life cycles. Also, our collaborations, we frequently collaborate with DataCite around persistent identifiers. And so we'll talk about that a lot today. And then also a project that we help lead called DMP Tool, which is a data management planning tool. And so these are some of the projects that we bring to the table in this project. And then I'll hand it over to Vaida to talk a little about RSpace and continue with some of the workflows that we've been prototyping.
Great, thanks, John. So as mentioned earlier, I'm Vaida. I do product management and kind of product spec at RSpace. And I wanted to start by giving a bit of a broader view of what RSpace is, what our sample management platform looks like, and then how the FAIR samples work that ties in with our existing features and how it helps kind of explore this whole end-to-end sample management workflow. So RSpace itself is an open source platform specifically for institutional research data management. So what does it actually mean? We have a sample management system, we have an electronic lab notebook, and these are together like integrated so that you're able to link your experimental write-up with your samples. But there's also a lot of integrations that we support with external tools and repositories, because we understand that people have a lot of specialized and generic tools that they like to use that are good at what they do. And we're not trying to become the tool that replaces every single other tool. We're here to really integrate and help support existing workflows and try to integrate them better to enable better FAIR practices. So I've got this diagram that has a lot of different logos, but I just wanted to quickly show that just to show what tools we support and how we focus on taking information from the preparation stages of research, link that to items you might create in active research, and then eventually push all of those bundles of data into external repositories. So talking more about the sample management and inventory platform, this is just a screenshot of how you would normally have it set up. On the very left, on the sidebar, you'll see a few of the different concepts we support. So nothing too unexpected here. You've got samples, you've got subsamples, you've got templates, so the ability to create structured sample entry. You've got containers that then can contain different containers themselves. You've also got a bench area for samples you're currently working with. Then you've got the left portion, which is a way to navigate through the representation of your lab you've got. So that will contain probably various containers representing your different lab freezers, your different 96 well plates and so on. And we've got various filtering systems so you can get exactly what you're wanting. And then on the right side, you'll have all the metadata of the item you're currently viewing. So this might include various attachments and various details about that item. So I already mentioned, the samples and subsamples concept. And for containers, we really tried to design inventory in a way where it is both really visual, and so it tries to really replicate what you've actually got in the lab, but also make it quite flexible in how you can represent the information, either for different people and how they work differently, but also different labs and how they like to organize things differently. So you might have a grid container that will represent an actual plate you're working with. You might have a visual container where you take an image of the actual organizing object you've got, such as a drawer unit, and then allocate it different containers so you can exactly know where things are placed. And you can also tunnel down items in a tree view when you're viewing inventory so that you can find exactly what you're looking for. And here's another example on the left-hand side. If you're working on a mobile device, for example, you might want to scan through things with card views, and you're able to see with the little annotations what types of items you might have in a container, or you might like to work more in a list view format, where you have more metadata at a glance about specific objects. So really a focus on it being usable on tablets and mobile devices and being flexible and visual. Here's another example of, let's say you're viewing a very large grid container. One aspect that'll come a little bit relevant later on that I want to mention already is also that integration between inventory and the ELN system. So we've got this concept of a list of materials, which allows you to link samples that you're using in an experiment to the actual experimental write-up. And that's quite helpful because you're then able to quickly decrease the quantities of a certain item as you're using it up right from within your document. And it also means that as you're exporting an experimental write-up to a repository, you can then link in those samples because they've already been linked at this list of materials stage of the process. And one small thing as well, I think that that's quite useful to know as well in terms of our approach is that you can both import samples using a CSV, so like from an Excel file, for example, but you can also export data to a CSV. So the idea there is the data is not siloed to the specific system, and you're able to import samples that you already use with different tools, and you're able to export them if you need to submit them in a, let's say, as a CSV format to a repository. So really making sure the data is really portable. And now I wanted to quickly overview what our existing integration with IGSN IDs does, and then explain how we really build on top of that for the Fair Samples project. So I'm sure most of you, probably all of you, know what IGSN IDs are. They're persistent identifiers for material samples, and they're provided by DataCite. And so we've built support for the core lifecycle of IGSN IDs within inventory so that the PID usage is available where you are already working with your samples. So there's not that kind of segmentation of, okay, I need to add an identifier to my sample. I need to go to a completely different system. I need to figure that out. I don't remember my login. Instead, you're working with your samples in one place, and you can directly interface with the PID registrar from within that. So we hope that simplifies the process for users and managers. And the idea is really to then embed persistent identification into your normal workflow. So it's not like extra work in any way. It's just part of your normal day-to-day work. So what we support currently is that you can create a draft IGSN ID. You can populate its mandatory metadata. In fact, when you register an IGSN ID, we automatically populate the metadata based on the information we already know on the user from the fact that we've got their profile on RSpace. We populate some recommended fields. Then we publish and generate a persistent landing page. And you can also associate a ROR ID, so your institutional ID, as part of that metadata as well. And then you can see on the left here, it's the part of the GSN ID editor within RSpace, and you can see that there's some information around the actual GOI and some required metadata. And on the right side, you have the public landing page, and at the bottom, you can see there's also even some interactive geolocation widgets that we support. So we really enjoyed working on all of this functionality, and it creates a comprehensive little bundle of work. But for fair samples, we really wanted to take a step back and think about the actual end-to-end process. So if you are a researcher and you're going to be working in a remote environment, you're going to be collecting samples in the field, then this is RSpace GSN ID work. Okay, that's really helpful, but that's not going to work offline. And you're also going to want to eventually deposit your samples to a repository, and RSpace isn't a repository tool. So how do we link all of the different tools you might use in an end-to-end sample workflow in a realistic way, in something that's manageable, that actually works, and that simplifies people's workflow, but without kind of creating this behemoth of work as well? Like, how do we focus on the exact things that people need to do? So we worked with a couple of institutions to figure out some generalizable workflows of how exactly someone might go about their work in the field. And these steps are what we came up with, and we tried to also account for some flexibility in how people might use these tools to really experiment, like how exactly these integrations might work. So just to go through these quickly, and then I'll go into more detail into how we actually implemented these. So someone, a data manager or maybe a user, might want to pre-register some IDs before going in the field and printing out a raffle book they can use to then label those samples in the field. They might then want to collect the metadata in an offline way on a mobile device in the field and make sure that the IGSN IDs are associated with that metadata. Once they're back from the field, they might import that sample metadata and want to make sure that the IDs come with that metadata. Then they'll want to do some editing of that metadata, publish a landing page. They'll want to link it to their experimental records. They might sometimes put that sample back, and then once they take it out again, want to be able to easily refer to that entry in the inventory system. And eventually they'll want to deposit that sample in experimental data and make sure that the IGSN IDs, again, carry with all of that work into the repository. So that's a lot of different steps. So if we go through them kind of one by one, I want to just talk about how we implemented that and what's interesting, and the things that came out to us as being interesting design decisions as part of that. So we implemented a pretty simple IGSN management page that allows you to bulk register a certain amount of IDs and then generate this printable page that contains both the QR codes and also some human readable metadata. So you can have like a raffle book style kind of printouts where you have the label twice, and so you know which ones you've used. And so in the field, you can stick those labels onto the samples. And once you're back from the field, we can import those in and link them back. But what's interesting about this is that I'll talk about how we integrated this with FieldMark, but you can also use already this step is enough to use just offline Excel sheets and an RSpace CSV import. You could just easily print out these sheets and then use the actual numbers and put those into an Excel sheet that contains also metadata entry, and then eventually import all of that back into RSpace. So there's flexibility to use very simple tools, but you can also vary that and use other tools, and that's possible because we're using like a very common format for handling the data of those samples. Then the field mark integration is really what allows us to do some fancy offline collection. So field mark itself is an open source product that allows for structured sample metadata collection. So it's designed for offline use. There's a good mobile app, and it allows for creating really clear templates with ontologies and for fields for images and for creating GPS coordinate entry. So it's meant to allow people to collect samples in the field in a structured way. And so we've built a field mark importer, which allows you, when you're back from the field and you've collected all of this information, to then import data from field mark into RSpace. So in the background, what happens is that RSpace creates sample templates that exactly correspond to field mark templates, so you're not losing any metadata. And the project metadata is also transferred, and then we create new samples based on that sample template. Yeah, that's just an example of how that looks. So when you're in the field and you're collecting metadata in field mark, you just have to make sure that your template has an IGSN ID field with a QR code kind of state, and that allows you to then easily use your phone camera and just scan in those QR codes, and the IGSN ID is then part of the metadata kind of record for that sample. And then when you're back from the field, import from field mark to RSpace happens. And the thing that's interesting about this is that initially we thought that every single tool in the chain would have to be very PID aware and very PID integrated. So a field mark would have to have its own integration with DataSci and a bunch of features. But actually, in this case, field mark doesn't actually have to know what the IGSN ID is. It just needs to collect it and maintain it in an appropriate format and then pass it on to RSpace. It records it and it acts as a conduit for the PID. And this avoids essentially field mark needing to be a PID provider and have PID functionality. So I think that was interesting that different tools don't need to have the same level of PID functionality. Then the next step is, let's say you're scanning, you're back from the field, you're scanning the sample with your camera, and you want to be able to quickly access the metadata that was imported in RSpace. We just added support for barcode scanning. And the only interesting thing here to mention is there is that whole question of, well, IGSN IDs are going to be public, but at this stage in the research, they might not be public yet. So there needs to be an internal way of finding those IGSN ID records. So that was just something needed to consider. Then when it comes to repositories, so taking data in IGSN IDs and depositing them, that's obviously a critical step of the process. And our current focus is on providing support for sample deposits into repositories. So in RSpace, you can already associate samples with experimental data, like I showed you in that list of materials example. And you can also export work and files directly from RSpace in a nice bundle to a repository. So we support some generalist repositories like Dataverse and Figshare, Zenodo. And so the really interesting bit would be if you selected a bundle of documents in your workspace in RSpace, and those had lists of materials, so a variety of samples attached to them because they were used as part of that experimental write-up, and those samples had themselves IGSN IDs, then RSpace is aware of all those links and is able to then take those IGSN IDs and provide them as related materials to the export as metadata. So that would be a really nice way to make sure that the IGSN ID travels from the very beginning, from the creation of the IGSN IDs before the field trip to the very end with all of its metadata. So the current work we're doing is a proof of concept, and it's with a generalist repository, so Dataverse, just because we already have a general integration with them. So the idea is to add IGSN IDs to a related materials field in Dataverse, The interesting thing about this is that, again, it has allowed us to define a little bit better the roles and responsibilities. So RSpace pushes all of the metadata information to DataCite, and DataCite then is able to provide this global commons that's easily accessible of different IGS and IDs. And so Dataverse can fetch the latest information on the IGS and IDs through DataCite and could, for example, show a nice preview card of those IGS and IDs. And DataCite then serves as a single source of truth for this information. And so what's interesting here is that Dataverse does not need itself, again, to take over the stewardship of the IGS and IDs or to provide a bunch of management features. It is able to query information that is already publicly available. And this also avoids issues where, let's say, someone, if we provide a Dataverse with access to those IGS and IDs for editing, then you might end up in situations where someone edits a sample in RSpace, also edits it in Dataverse, and then pushes updates, and then there's conflicts. And instead here, you have this nice kind of setup where Dataverse is querying the information, similarly to how FieldMark then is a conduit. Meanwhile, RSpace is more like an editor of it and then is able to push the IGSN ID and link it to other items. So different tools have different roles, and it avoids every tool needing to serve every role and like a ballooning of development effort as well. So when it comes to domain repositories, this is the part where we really need your feedback to understand what would be the ideal workflow for submitting sample data to domain repositories. And for that, I just have a couple of things that were on our minds, which is like, what is your current workflow for depositing? What gets submitted, and how are the experiments actually linked to the samples? What would be, in contrast, your preferred or ideal workflow? And which repositories do you submit to as well? A couple of things we're already aware of is some domain repositories we know have a manual submission step, so you have to actually email someone, so there's no kind of direct API support. And we're aware of also the variety of metadata schemas that sometimes are a little bit conflicting. So I'd be really curious to hear how your feedback on all of these questions, and feedback on the whole talk in general as well. We're looking forward to the conversation, and yeah, from John and me, thanks so much for having us and for inviting us to talk here. I hope that was interesting. Thank you.
Thanks so much, Vaida and John. That was fantastic. Really interesting to see all the work and the integrations and kind of protocols and best practices for integrations. Questions for John and Vaida? You can either put them in the chat or, yep, you can come off mute. Go ahead, Brian.
Yeah, I kind of didn't quite follow the Dataverse part. So is Dataverse capable of handling IGSNs as a asset? I mean, is it our repository? We're a DataCite member and we use Esploro for our repository, but I can use Fabrica or Fabrica or however you pronounce it to create records. But I've been exploring with Natalie about, using their services to handle physical samples. I just couldn't quite follow the process for using Dataverse that you were reviewing. Does that make sense?
Yeah, no, that's fair enough. I think I kind of didn't quite detail that very well. So the way we're thinking of using it is that Dataverse does support some kind of custom scripting for various fields. So it is possible, for example, the simplest way would just be for us to pass the IGSN IDs as URLs to Dataverse in a kind of related identifiers field. But it's possible to make that a little bit nicer, where there could be a script that would take those URLs, query them and get, let's say, the name, the owner, maybe the institution, and then show those as like a nice kind of HTML widget on Dataverse's side. So it's not like a very deep integration, but it would encode the actual IGSN IDs in the metadata of the export and could provide some kind of nice viewing of it. Yeah.
I'm also intrigued by the what RSpace is. I'm not familiar with it before this, because we've got groups that go out and do air sampling, and it's destructive analysis of the materials that they use. They use polyurethane samplers, put it in the air, and then it absorbs PCBs from the air, and then they take those back and they extract the PCBs to see what the air contained. And this seems like it would be a nice way for them to have a kind of a chain of custody more established with those samples. Not that they don't have some process for that, but this would connect it more to from the sampling all the way to the analysis. So that's kind of cool. I'll have to follow up with you.
Yeah, that'd be great. Yeah.
Looks like we have a question in the chat from Plato. Plato says, great presentation. Can you discuss plans for project sustainability beyond funding support?
I think like maybe also just building off of Brian's question as well is, one of the main research questions we had with this eager was around open source tooling in general. So as we all know, there's a lot of vendors and a lot of cost in the work that we do. And what we wanted to be able to prototype out and look at was how do we leverage open source and open tools that can use well understood open APIs and interchanging formats for us to be able to bring things together, leveraging persistent identifiers and other protocols to make that happen. And so there's a sustainability question about the project work, meaning like how do Vaida and John and the teams continue to work together? But there's more of a like the research workflows and the ideas that we're prototyping. And from that latter category, there isn't a need for a sustainability plan in the sense that the workflows that we are championing, the ones that kind of showcase how going from an open source tool platform like RSpace to an open platform like Dataverse using IGSNs and using the samples management system as well as Fieldmark as management systems. These are intended to showcase that there is already a robust enough open set of tools that we can, as a community, can start to leverage. And by using them end to end, we're able to then showcase that value and then also help them get better and better and have a more direct impact to researchers.
John, just to clarify, though, so if I, as a researcher, wanted to start to implement RSpace for a wide variety of processes in my lab, there's a paid membership for that. Is that right? Or a subscription or something?
I'll let them just discuss that. I think there's multiple options. So yes, there is a paid membership, but there are multiple options. Yeah.
Yeah, I think the best example is something like the Nextcloud model, for example. So it is an open source system, so you can implement that yourself. But we also offer kind of paid kind of hosting, support, and training. So that's another benefit, is that it's not that the Fair Samples project just kind of created RSpace and then afterwards there's no support for it and there's no support for Fieldmark or Dataverse. These are existing projects and we're building on top of them and trying to plug them together and seeing how that would work. And that is the kind of core of the project. So I think that really helps with the kind of sustainability aspect of it as well.
Apologizing for jumping in here, but I can't resist. I'm Vaida's colleague, Rory. So I think one aspect of the sustainability relates to the RSpace business model, which is kind of your question as well, Plato's question and Natalie's question coming together. So RSpace is open source. So we have, as John says, we have a variety of delivery mechanisms. We actually have a free community version, which is intended for kind of orphan researchers and labs whose institutions don't provide an institutional solution. We also have the open source version, which any institution or any group or any individual, for that matter, can spin up their own instance of RSpace. And then that's all fine, but we don't make any money off that. So how do we survive as a business? So we also have an enterprise offering where we provide services and support to institutions, i.e. universities and research institutes, in exchange for an annual subscription fee. And interestingly, we're now actively, I'd say, pioneering, exploring a new category of customer, if you will, a new platform, which is the national and regional research infrastructures, which are being set up, not so much in the US, but Canada's doing it. In EOSC, it's happening at the European level. In Australia, some individual European countries are beginning to understand that there's more value, that it's difficult for each university to provide the full set of necessary research infrastructure, and in fact, they're putting together integrated research infrastructures, and RSpace is being considered as kind of a glue or integrator because of this workflow support, which you just seen a little bit of it today. So RSpace is sustainable. I mean, we're profitable. I mean, we break even, and I think we're quite stable. We're not the next Netflix or anything like that, but that is an aspect of the sustainability. Yeah.
Thanks. Yeah. We heard last month from CSIRO, who I think has implemented RSpace for some of his workflows. Yeah.
Yeah.
We have a. Oh yeah, go ahead.
No. Yes, that's right. Sorry. Yep.
We have one question in the chat from Andrea. Andrea says, where are the sample metadata records being shared, and are they searchable?
Yeah, so the way that DataCite does its metadata kind of recording is that the core IGSN ID schema and its fields are collected by DataCite as like a global registrar, and that's all searchable. Not just online and through API and kind of programmatic ways, but it's also understood that a lot of samples will have custom metadata that doesn't fit the IGSN ID schema, and so all of that information is then available on those landing pages, and those landing pages are linked from the DataCite metadata schema and recorded in DataCite. The idea of next step would be to make those landing pages also kind of very programmatically encoded, so that all of the information within them could be queried as well. But that's the way it kind of works right now.
Andrea, do you have a follow-up? Maybe not. Okay, we'll wait for Andrea's follow-up in the chat. Brian asks in the meantime, oh, there we go. So it's RSpace that's hosting the landing pages?
Yeah, this is the way we've implemented it as like a easy to use feature if you don't have your own kind of system for recording landing pages. Because if I know some institutions have their own systems for landing pages, and then what you could do is export the information from RSpace as a CSV or however else through an API, and then create landing pages externally. But what we provide here is just kind of an easy to use solution, which is from RSpace, you can publish them and they sit right next to your kind of RSpace instances pages that you don't need to sign up to, but they're just available and hosted by RSpace. Yeah.
Brian asks, how are different domains handling core metadata and also domain metadata in RSpace?
That is a good question, and I would love to do more user research on that. The way we've implemented it, at least I can speak to that, which is that we've made it so if you're recording additional metadata about a sample that's not part of the IGSN ID schema, there's a switch you can flick so that all of the information from the sample all shows up on the landing page, whether it's IGSN ID or domain. So that allows you to kind of quickly reproduce all of that information on the landing page. But what I do know is that some people are trying to see how far they can push the data site schema to record domain-specific information, while some others are deciding, okay, no, that this is just to make it easily searchable. Let's just put the core information in, and everything else is just in landing pages, and you should just make sure that we're using all of our ontologies consistently within our domain. So there's really many ways you can go.
Yeah, definitely a topic of discussion in this group and at Caesar as well. Yeah, Rory.
I was just going to say, I think, as Vaida said, this is a really active topic of interest for us right now. Is having better support for metadata schemas and different domain metadata schemas in RSpace. And so the only way we can do that is by engaging with, we don't have the answers, we just have the questions. So if anyone on the call or anybody else that's engaged with ESIP is interested, we'd be delighted to, get their input into what we should do. And yeah, I was just going to say there maybe just there's a lot of interesting activity going on. So, for example, we're another project we're involved with at the moment. It's called PIDS, PIDS for NFDI or NFDI for PIDS. I always forget which. So it's the German infrastructure initiative, one of the initiatives of the national German infrastructure, and that is specifically tasked with looking at. It's not sample related, but it is metadata related, tasked with looking at better interoperability between data management plans and electronic lab notebooks. And RSpace is kind of the example electronic lab notebook, which is being used. And what they are looking at, they're also working with another NFDI called TS for NFDI, which is terminological services. And they are looking at building the ability to have crosswalks between different metadata schemas that are used in different tools, so that even if the metadata schemas are different, it would be possible to easily exchange the metadata between the different tools to achieve interoperability. So that's another kind of angle, if you will, on metadata interoperability. So that's quite an interesting project if anyone's interested in learning more. Yeah, sorry. That's that. Yep.
Rory,
And then
if people are
sorry,
interested in learning more, is there a spot on the web to point them to?
Absolutely. And if
Okay.
I'll if you give me a second, I'll find the link and put it in the chat. Then I was also just going to address Plato's question about will the work from the project be in the paid version or the free version? Everything is in the open source version, which is free. So the answer is both.
Yeah, we only have a very small amount of things that are not available in the open source version, purely because it's like custom things like single sign-on, which is, very dependent on institution that we can't just like provide. And chemistry used to be something that we couldn't provide because we were using a proprietary system. But recently, earlier this year, we actually fully migrated to open source chemistry tools. So we're able to provide those within RSpace as well. So yeah, everything is in the open source version, essentially.
Other questions? Leslie has noted in the chat that if anyone's going to RDA P26, the RDA Physical Samples Interest Group is hopefully going to have a session that covers the topic of domain metadata schemas, assuming the session is accepted.
Great.
I was just going to also bring up, we didn't bring this up earlier, but Vaida and Rory have been championing this idea of vertical interoperability, which we've done some other workshops and blog posts about. And the concept of is not, it's not new to this team here, but just to explore it a little bit, it's this idea that often when we have conversations in these types of circles, we're talking about interoperability, but when it comes down to it, it's very much a horizontal focused interoperability where we, maybe talk about repositories and we talk about how all the repositories should have similar approaches to things so they can be interoperable, but without necessarily a research focused question being answered, like which researcher is trying to move things from one repository to another. And the idea of vertical interoperability is really saying, like, how do we build interoperable processes that are focused on actual workflows that have distinct kind of through the tool chain, through the lifecycle value to research. And so the larger research question that we're bringing up here is how do we start to champion and prototype out vertical interoperability projects using open source tools to achieve our goals? And how do we do that in a way that leverages existing tools and not reinventing the wheel? And so hopefully that kind of came out in the presentation as the general framing that we are bringing to the table. Not necessarily something that's new, but something where, a full open source tool chain is something that has been lacking for some of these workflows. And so it's been great to be able to explore them here.
Yeah, I think it's interesting to think about maybe like how this plays out for discovery and searchability in ways that users need to be able to search, and that balance between, I guess as we see the balance between varied metadata schemas coming from different IGSN providers, but wanting to yes, like have user community recognized community specific metadata, but then bringing things into these aggregators that are gonna make samples even more reusable than they are now and discoverable. So I think it's interesting to hear about the NFDI crosswalking work, because I think the crosswalks will become more and more important then.
Yeah, I think Rory just put the link in the chat for more information about
Thanks,
that.
Rory. Yeah. Brian asks, are there materials available on the use cases you've described?
Use cases in terms of what researchers want to do with PIDs, because I do have as part of that actually previous project as well. But in terms of this project, I don't think we've got a bunch of kind of presentations we've done, but I don't think we've got like a summary write-up on it yet, because the project is also still ongoing. But we will eventually have that. Yeah.
But
Yeah,
I'm just thinking about it. One thing which I think might be interesting and relevant is the earlier project you did, the EOSC project with the sample, with the IGSN, where you worked with some geoscientists at UIT in Norway and some plant scientists at the Rothamsted Institute in England. And you did quite a detailed work where they described the institutional workflows that need to be supported. So, and then you and Xiaoli from DataCite did a really nice report on that. So I don't know if you can quickly find a link for that, but it's on Zenodo, so that would be interesting, I think.
Yeah,
I was able to find that. Yeah.
I don't want to add to your your workload. I just thought if you had some stuff that I can pass along to other people that I can say, here, read up on this. This is the workflow. This is what's involved. I'm encouraged by what I saw today. One of the challenges I've found with some open source tools is quite often you have to have a programmer on your own staff to support and maintain the system. And as you guys know, not all of us have that kind of a budget or staffing. And I do like the emphasis on sustainability. And I think we've all seen projects that have looked really good and then they disappear, or else they eventually get purchased by a for-profit commercial entity, and things change radically then too. So, but thanks overall. This has been really good for me anyway.
Yeah, I'm glad to hear. Yeah, I was able to find that art publication, whatever it's called, in Zenodo. But yeah, I think it's quite good in that I don't just cover use cases, but we really try to talk about the process of obtaining them and the steps from going from use cases to actual feature specification to kind of design principles. So that could be helpful in terms of even figuring out what is needed within, you know, your own kind of context. Yeah, hopefully that's useful.
Yeah, and the article that Natalie pasted in on the DataCite blog was I think Vaida co-authored with Rory Edmonds, and it talks more about the IGSN workflows that we are experimenting with. So there's definitely documentation available.
And we'll make sure we get these links in the notes so people can reference them later as well. Other questions? Anything from Vaida and John while you have a captive audience?
Yeah.
Or Rory? Awesome.
Yeah,
Well,
thank you for having us.
Thank you very much.
Yeah, thanks so much.